Okay, let's make a new solution. Well, you can pen around this field and draw some lines. The goal is to move electrons from one port to another, reconstructing the pattern shown above. Basically, one port emits electron and the other is receiving them. You can draw wires, and the electron will travel by wires by some rules. Also you can undo, and rules are basically Wireworld rules. You can directly put electrons there. To make it directional you have to put head and tail, so it will basically travel like this. Now this is our goal. So we have to draw a wire from one port to another and see how well it goes. Basically we are fulfilling this level and going to next one. Next level is a bit more complicated. You have to connect as shown above on port 1 and 2 and 3 and 4 because they have same patterns. And you can do it by creating generators with electrons, but I think more interesting is to connect wires. Okay, next level is a bit more complicated. You have to use some bridges. Basically this is a typical bridge, and this is a bit more interesting bridge. And you can connect wires to them and make sure that, for example, 3 can go through 5. Output of port 3 can go through wire for port 5. Let's draw something here. Also you can zoom in, zoom out, and connect it some way. And now we see a bit of a problem here. They are cancelling each other. You see, every bridge requires some kind of phase for electrons to get in. And basically they have a period, a minimal period, which they can work with. So we have to make one input longer to make sure that they aren't cancelling each other. Okay, it looks like they aren't cancelling each other, and now we can go from 3 to 4. Okay, let's see if we have input 4. Yeah, input 4 is good. Now let's connect other ports. We have to replicate this thing. You can pick it from these logic primitives and gadgets and stuff. Here are bridges. My favorite is XOR bridge. It's very straightforward, and you can represent it mathematically. Well, we have here a conflict, so we can just undo it and put this XOR bridge again. Now we will have a signal from port 5 intersecting with signal from port 1. Port 1 is a very tight signal, so it might get difficult to move them together through the same bridge. We have to calculate best phase possible. We can make some of the inputs longer or shorter to make sure that the electron will come in a good phase. For instance, if you just will do it like this, it won't change anything, because electron will travel diagonally the same way as it goes through the line. But if we will make some kind of loop, then it will go a bit more further. It have to travel further in order to reach this bridge. So we have to just grow this loop until it will come through this bridge well. Okay, looks like it works. Game supports portrait mode, which is much more suitable for playing on the iPhone, but current video is better in landscape, of course. So let's connect the remaining ports. Okay, we have a problem with the port 2. You can check details on this and see that they have around 16 steps, and on the 16 steps it just fails. So period is 15 steps, but on the 16th will be next period starting with an electron. So basically this last bridge we added is cancelling out something, so we have to make this connection loop a bit more long. Here we go. No, not yet. Even longer. And even longer. Now it works. You have all solutions here. You can go back anytime. And now this is more interesting. We have an alternator here. We have two kinds of alternator, but this one is a bit more complicated, so let's use the first one. You can find them anytime you want and put them any place you want. So let's try it. Alternator basically puts electron from input to first and then second, first and second output. It alternates. Okay, now you go by yourself.